So, with all of our previous videos combined, we now have a first-person controller script using mouse input, keyboard input, and a player movement class. So now we can look around, we can move, we can see what's going on, and we can walk off the edge. Beautiful. Beautiful things are happening here. So, now that we've got that handled, we're going to want to create some stuff. So let's add another folder to our plethora of folders already. Let's add a new folder, and this one's going to be called Materials. So the Materials folder is where we're going to create, yes, materials. So let me create, so you right-click, Create Material. So this creates us a standard material over here. We're going to call this material Player Mat. So this is the player material. So we're going to, the easiest way to apply material to an object, click, drag it directly to the object. Now it doesn't look a lot different because right now my player material is white. But if I come over here and I take this and I tint it, so we're going to, because it's a player, we're going to make that player a blue color. And you'll see that now our object has been changed to a blue. So I can actually move the color out of the way, and you can see that as I change this, it changes colors. So I can change it from red to green to blue. So I like this blue color right here. So we're going to make our player blue, and so then we have our ground here. So this is a very, very tiny platform for a player to be on. So what I'm going to do is I'm going to make this 100 wide by 100 tall. But wow, that's a lot of white. That's that's a lot of white. Look at all that white. So I don't like white. So we're going to create a new material, and I'm going to call this ground mat. So this is the ground material. In this case, we're going to create like a brownish color, like this right here. So this brownish color I can apply to the ground. So now you can see that the ground is ground. Now this is huge. Look at how enormous this is. And so we have this giant ground and then the player in this giant field. So we obviously have to put things here, right? So let's make this 0, 0, 0. And now we're going to look at creating our city. So if you saw in the example in part 1 or part 2, in the first video where we covered any kind of Unity stuff, I showed you that it generates a city so you have to walk around buildings and things like that. So we're going to create a city generator. So I'm going to create a new empty game object. I'm going to call this city generator. And then we're going to go to our city generator folder in our scripts down here. Scripts, city generator, and we're going to create a C# script called city generator. Now, before we move on, I know one thing right off the top of my head. I'm not going to want to create meshes and things like that for this thing. It's for this. So let me create a 3D object, and I'll call it a cube. Right? So you got this fancy cube block. Now, if the cube block was touching the ground, this would be cool. This would be a building. I mean, it's a small building compared to the size of the player. If we wanted to zoom out here, let's move it in range of the player here, so that I don't have to walk very far. So let's fire up the game, and then I can look around and I can find our box. So this box is definitely not building sized, but that's okay because we can scale the box up to a building size. So that's what we want to happen here. We know that the cube is 1 by 1 by 1. It's 1 unit by 1 unit by 1 unit. So if I wanted to if I, for example, said y0, it's 50% in the it's 50% in the ground, and it's 50% above ground. So if I wanted to make it perfectly on the ground, I'd say 0.5, and it would be exactly touching ground. Now if I created another cube, I want it inside the cube. I want it outside the cube. And I wanted to make this 1.5. It would stack on top of each other like this. Or if I wanted to make one block the same height as both blocks combined, I can take this block and scale its y value by 2. And then put this at 1.5. No, so at 1. Yeah, half the height. So now it's the same height as both blocks were combined because it's a scaled of 2. And so the higher I scale this, the taller this becomes. Again, also similarly, I created it very tall, right? It's 125 tall. I could also, for example, make it wide. So I can make it 5 by 5 by 5, and it's a really fat block in comparison to its original because it's scaled. I hate when that happens. It's scaled to the value 5 times as large as this. So if this is 1 wide, this is 5 wide. Simple. So in this case, the block is actually half the height because I know that this is actually a height of 2. The capsule is actually a height of 2. Which is why I need to put the y value at 1. So in this case, the block is actually half the height. So let's delete our cube here and delete this cube, and let's create our cube 3D object. So we got our cube 3D object over here. Let's bring it over to us, and we're going to add a material to it because we're obviously coloring everything. So in this case, oops, I don't want to create a C# script. Thank you. Delete that. Get that on my site. So I want to create a new material, and this material is going to be called building mat. So it's the building material, and this building material is going to be a gray color because buildings are gray. So we're going to attach that to this and name this cube building. And then we're going to actually drag this building into our prefabs folders, which we haven't touched yet. So here's the first prefab we created. So what this means is I can do this, and I can create as many buildings as I feel like, and I can stretch them out everywhere, and every single one of them I can put on different things. But an interesting thing with prefabs is that they all take on the base principles. So, for example, let's say I don't like the gray color anymore. So I'm going to come over here to the building mat on our object, and I'm going to come and I'm going to change it to red. All of the prefabs that come out of building are now red instead of gray because they all share these properties. As soon as I move them, you can see that these are bolded. These bolded values are different, have been changed from the original prefab. So that means that they do not any longer have, so if I change the prefab value here, they don't move because these have been updated from the prefab. But the building, so this specific one's color has not changed either. But these values, like the building mat and things like that, they all share. So this collider doesn't share. You notice it goes bold. The scale doesn't share unless I come to the prefab and I scale the prefab up, and then they all share the same. But we're not going to be touching the prefab because we just want the building block prefab. So we actually don't need that anymore. It's still right here in our prefabs list. So the reason I did this is because what I'm going to do is instantiate a prefab. So I'm going to put the prefab out in the field. I'm going to put it right there on the ground, and then I'm going to say it's going to be 10 wide by 10 wide, and then it's going to be 40 tall. So that is a building, right? And it's going to go up to 20 tall, right? So that's a building. I've now crafted a skyscraper, right? Great. So now that I've crafted the skyscraper, I want to create a billion skyscrapers. But that's not going to happen unless I can do that with a script. I don't want to manually place each object in this case. So I just want to create them with a script. So let's hop back over to our city generator script and open that up in Unity. So we're going to talk about arrays now. We're going to create a two-dimensional array of height values. So this is going to be a float array, so we use these square brackets with a comma in the middle stating that there's two values. There's an x and there's a y value to this array. And we're going to call this the city blocks. And then we're also, just like we did in player movement here, where we did a public camera, this is also, so because camera is a game object, we can create a public game object, and we'd be able to use that to clone an object. So in this case, we're going to do public game object building prefab. So what this means is that if I clone this building prefab, then it creates a brand new object in our game scene, which is awesome. So in this start here, I'm going to want to initialize city blocks. So city blocks equals new float array, and this time we're going to designate it as a 10 by 10 array. So our city is going to be 10 buildings wide by 10 buildings long. So in that case, we can then go and create our city blocks. So we're going to start off with a for loop, a nested for loop. So for int I, which we're just going to use as a random variable for counting. Most examples will use I and C, which is the two variables we'll use. For int I equals 0, so we're going to start with an I value that equals 0, and then we're going to iterate through this loop until I is greater than or equal to city blocks, or wait, I'm brain farting. I can't remember if we iterate while it's less than or if we iterate until I is greater than. Let me just double check my city generator script. It's less than. Okay. So while I is less than or equal to city blocks dot get length of the first dimension, so the 0 dimension, then so while it's less than that, so in this case the 0 dimension is this first value here, which is going to be 10. So while I is less than 10, go through this loop and then increase I by 1. So in this case I equals 0, it'll iterate through the loop, and then I equals 1. I is 1 is less than 10, so do it again. Keep doing this until I is equal to 10 or greater than 10, or greater than 10. So in this case, it'll reach 10 and it'll stop. So it'll do 0 through 10. In this case, we actually don't want it to do that because we want it to only go 10 wide. So in this case, we're going to say -1. The other thing we could do is we could say this. So until it is less than, iterate through this while it's less than 10. So being equal to 10 is not being less than 10. So in this case, it would be the same as saying less than or equal to 9. So we'll just do this for now. And then we're going to actually make another one of these right inside of that one. But instead of using I, we're going to use the value C for count. Right? And we're not going to use the 0th dimension, we're going to use the 1 dimension. So what I could do is potentially make this a 30, so it would be 10 by 30, and that way it'll account for the length, the difference in length. But we want it 10 by 10 for right now. 10 by 10 is going to be very large. So for IC, basically those are now coordinates in our two-dimensional array. So you'll see in the values, you would see 0, 0, 0, 0, 0, 0, 0, 0, all the way up to 10 wide, and then you would see another line that is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, up to 10 vertically. And so what we're going to do is, for every single one of these ones in there, we're going to assign it a number. So it's going to be either 0 or 3 or 2 or 1. All these values are going to have either a number or 0. So in this case, we're going to create a random number between two numbers. So we're going to want a minimum height and a maximum height. So first off, we'll go city blocks, and then we'll do IC. So this is our XY coordinates in the city blocks array. And then we're going to set it to 1. So every single block is going to be equal to 1, right? And then we are going to do this, iterate through all of this over again. And then we are going to, instead of doing that, we're going to do if city blocks IC is equal to, so we use the double equals. 2 equal signs is a comparative. So city blocks double equals 1 means if this equals is actually equal to 1, say it's true. A single one is just saying set city blocks equal to 1. It's not comparing anything. So we want the double equals. City blocks IC. If it equals 1, then we're going to instantiate instantiate, and we're going to instantiate a building prefab at new vector 3. So this is going to be the position vector. We're going to say it's going to be the I value multiplied by 1, or by 2, and then 0, because we want it to be at the 0 height, and then C times 2. And then lastly but not leastly, we have the quaternion. Now for this tutorial, we don't need to know much about quaternions. Quaternions are very useful. They deal with rotation. They allow us to describe a rotation of an object in all possible terms. So if I took an object and took its quaternion, I rotated it a bunch, took its quaternion, and then applied that to a new object, it would also have the same rotation. So in this case, because we don't need it, we're just going to use the identity so that it has no rotation. It's going to be exactly identical to the prefab. So in this case, we now iterate through and instantiate building prefabs at these locations. On a technicality, guess what? We're done. This is all we need for the city code. But you'll see why we're going to need to alter it in a second. So let's take our city generator CS here, and we're going to drag it, if Unity would finish, drag it up here to our city generator object. So we have our city generator here, and we have you can see that there's the building prefab, which we need to make sure we apply. So let's go down to our prefabs down here. We're going to grab our building, and we're going to drag it up to our building prefab. So now city generator has a building prefab that it can generate. And let us hit that go button. Boom! A bunch of blocks. It creates a bunch of buildings. Now, they're still 1-by-1 buildings. They're not scaled upwards. They're just 1-by-1 buildings that have nothing to do. They're just in a grid. But you can see what I mentioned earlier, is that these blocks are now in a 10-by-10 grid. I just barely fit through those. You can see that they're in a 10-by-10 grid of all of the blocks, and they're at a 0 height, so they're, whatever height they're at, and then they are positioned to a part. So if I were to actually go back into our code, let's go back to our code real quick, and just so you can see why I added the multiply by 2, if I were to set them to their IC locations, which is only basically its X and Y position in the grid, if I did that, you would just get one big slab of blocks. This whole thing is one big slab of blocks. Even though these are all individual blocks, there's no gaps in between them. So I multiplied by 2 so that they would just skip every other block. It basically, deletes this block, it deletes this block, and deletes this block, and this one, and this one, and this one, and this one, and this one. So it skips every other block so that it creates a grid. See how that works? So, in this case, those buildings are very tiny, so we need to scale them upwards. In this case, instantiate, if we look at it, instantiate actually returns a clone of or a reference to that object. So we can say game object temp equals instantiate. In this case, because it returns a generic object, not a game object, we're going to cast it to game object. If you want to know more about casting, I know it's a game object that's being returned because it's returning a clone of prefab, which is a game object. But if you want to know more about casting, I would say look that up. I'm not going to go into it too much, but basically this returns a generic blob of information, and I'm telling it explicitly that that blob of information is actually a game object. So now that I know that the game object is there, I can say temp, and I can manipulate the temp object however I want. So in this case, I can do transform dot scale, local scale, equals new vector 3. So now I can scale on all 3 vectors. I can scale on the x, so I'm going to say, but instead I'm not going to scale on the x, I'm going to scale, so I want to leave it at 1, because you scale it by 0, it has 0 width. So 1, but then I'm going to scale it by 10, and then I'm going to scale it by 1 again. So I'm scaling its y, its height value, by 10, and let's see what happens. So now this should be 10 very tall blocks. Oops, I forgot to add that xy value to get out. I forgot to add the multiply by 2. So it's still a big block. So let's add that back and then rerun this. So now we have our forest of blocks. You can look at it over here. We have our big forest of blocks here. It's a big grid of just tall blocks. Now if you look at this here, these blocks are actually taller than that. They're underground. So we actually need to transform them upwards by their height. So what I was mentioning before was that we were going to create a bunch of values here. So city blocks IC actually is going to contain a height value. So in this case, we're going to go random range, and we have a min value and a max value. So I'm going to say min value of 0 to a max value of 10. So now, instead of saying 10 here, by forcing it to be 10, I can say city blocks, instead of saying if city blocks equals 1, I'm going to say if city blocks is greater than or equal to 1. And then I can say city blocks IC. So now it'll get the value of whatever the height value of city blocks is in the as the height value. So now that we're creating a random range, these buildings will no longer be one height, they will be a bunch of different heights. So now you can see how this is starting to look a little more like a city and having a bunch of different height buildings. Now because, as I mentioned before, all of these are halfway underground, we're actually going to want to scale to move those up. So in this case, we're going to want to add a position change. So I'm going to do temp.transform.position, and then it's going to be what is it? Transform position. So because I already know where their x and y values are, I don't want to move them horizontally or forward or backwards. I don't want to move them that way. I want to move them vertically. I want to make them the correct height so they don't get buried underground. So in this case, I'm going to do transform position, new, vector 3, just like before. So now we're creating a vector 3 position vector. But this time I'm going to actually get the positions and put the x and z position in because I already know what they are. So in this case, I want temp transform dot position dot x, and similarly I will get the temp transform position y value, and then we're going to do city blocks IC. Now remember that we know that that's the height value, but we don't need the whole height because remember I'm burying them half in the ground. So I'm just going to take that and I'm going to divide it by 2. I'm going to divide it by 2f because I want to make sure that it's a float value that I'm dividing by, and that I'm going to make sure that this is a float by casting it to a float object, to a float value. Otherwise, we could get integer rounding happening, which I've had happen before. So let's go back here, and now the building should be. Oop, I definitely broke something. All the buildings are... Oh, you know what it is? I bet I changed... there we go. Position X, position Y. I want position Z. I did Y on the end here. So if you put that in your code, make sure that you fix that. If you copied mine exactly, make sure you fix that real quick. So anyway, you'll get the same bug and then see that in the video. So anyway, now that we fixed that bug, we can walk out here. So we can see that we have a city going on here. But the problem is the city streets are really thin still, and the buildings are the same width as the player. So we're going to change that. So I'm going to create a few public values that we can tweak, and these will make the whole process a little bit easier. So public float building spacing. So what this is going to be is a value of we're going to start with a value of 10. So instead of doing multiplied by 2 when I create the coordinates for it, I'm going to multiply by building spacing. And similarly for this building spacing. So the reason that that's the case, so now when I come back, instead of it being the buildings are really close to each other, you'll notice that the buildings are really far apart from each other, and they're now 10 blocks away from each other. There's a lot of space in between them. So now we can create another value, and we're going to call this value public float building, we'll call it building scale. And so we're going to say that the building scale is going to be 5 by default. You can always change these because I'm making them public. You can alter them in the editor, and we'll play around with some numbers and see what happens. But in this case, I want the building scale to apply to whatever the local scale is when we scale them up. So in this case, instead of being 1, I'm just going to make them building scale. So building scale, building scale. So in this case, now all the buildings are going to be 5 wide. So now the buildings look fat. We have nice fat buildings. Now you'll notice that the corridors between them are still spacey enough for us to do that. And you'll notice that this one doesn't have a building. That's something that's very interesting. So what I did was by saying as long as the value of the height is higher than 0, you'll notice that if I look down, it's a little bit difficult to do this, but if I look down at the grid here, you'll notice that some of the spaces are missing. That's because buildings were never instantiated because their heights are lower than 1. So, now that we have those two values, right, I can look at my city generator and I can make the scale, let's make the scale 10 wide, and then I'm going to make the building spacing 20 wide. So now we have really wide buildings, a bunch of really wide, short buildings. So we obviously want to be able to increase the size of this. So we're going to add 2 new values to our building generator. So the first one is going to be public float, float building min height. H-E-I-G-H-T. Building min height. So we're gonna make this 30 by default. Actually, you know, we'll make it 10 by default. And then we're going to have, so that's our minimum height. And then we're going to have a max height. And that max height we're gonna make 50. So now, those two values are really important. So what I'm going to do is build, so when we create our random range, remember this is the height of our building, I'm going to set the max height as 50, right? Now, it's going to create a bunch of buildings from range 0 to 50. Now, the reason I say that, you know, you look at this and go, well, why wouldn't I set the min height of the range? So in this case, I'm actually intending for some of the buildings to not get generated. It's going to generate them with a height lower than the min height, and then just not instantiate them. So in this case, instead of saying if it's greater than or equal to 1, I'm going to say is it greater than or equal to the building min height. So that way, if it generates a building that's lower than 10, I don't want to create it. That prevents me from seeing really short buildings that are like 1 high. I want them to be at least a 10, if not a 50. So we can see, you'll see that this also thins out our cityscape. So there's quite a few less buildings. Well, in this case, it looks like we rolled pretty happily on that. And so let's say, oh well, I think this building is too short. Well, in this case, this building is 10 exactly, right? Oh, we're getting rounding like I expected. So this one's 18, this one's 42, this one's 13. These should be able to be fractions, so they're only scaling as integers. Oh, they're scaling as integers because this is returning an integer value. I forgot how I fixed this. Let me check my code real quick to see how I figured out the range problem. I thought this was a random float number. Oh, it's because I'm not passing it a float value. So, oh, building max height, sorry. I wanted to make it a building max height, so as soon as I pass a building max height, it's now looking at the float, so it returns a float value. Okay, so that fixes that problem. So then on top of that, the min height is, the max height is fine, but the min height is too low. So now I'm gonna, let me bump this up to 20. So the higher I make the minimum height requirement, the more this city should thin out. I should start seeing less objects in the city generator. So let's see, building min height is 20, so we'll see that the city generator now produces less buildings. And then so again, as I go up to 30, now it'll only generate between 30 and 50, so now there's less buildings again. So now if I wanted to, I could do like 45. So now I only generate buildings that are between 45 and 50, which is a very sparse few buildings, you can see here. So that's how you can control the height. So now I can say, like, let's say I think those buildings are a little too tall. So now I can say, well, now I'm going to bump it down to max height of 30, but I'm going to do a min height of 25, and that should give me about the same. I forgot so. That's a good thing to note. If the editor is playing and you change any of the values in any of your objects, when you stop playing, it'll revert to whatever it was before you started playing. So let's set this to 25 again, and set this to 30 again, and it should give me the same sparseness of buildings, but now the buildings are a little bit shorter, which is perfectly fine. Remember, the player is too high, so if we're saying a value of 2 is we'll say 6 feet for an average person, then a value of 27 is 6 divided by 27, that many stories tall. So these buildings are large. They're not huge. They're not giant skyscraper tall, but they are definitely larger. So now, since we have some range going on here, which is really cool, what we can do is we're actually gonna do something that I didn't do in my other code, and so bear with me. We're gonna mess with some things. So now we're going to do something similar with the building scale. So we're going to say building min scale and building max scale. So, and we're going to want to account for this. Remember, we're going to want to account for this in our building spacing. So if our max scale is 10, assume that the object is going to have a max scale every time. And we want to make sure that the spacing, let's say our building has a 10 by 10. Right? And then we have another building that's a 10 by 10. We want those buildings to be spaced out slightly farther apart so that they have space in between them. So we're going to want building spacing to be about 15 between the buildings. So that even if they were 5 by 5, there's still plenty of space between buildings, but now if they're 10 by 10, there's still 5 value in between the buildings. So instead of building scale here, what we can do is we can, right before we do our local scale transform here, we can do a quick float temp scale x equals random dot range, and then building min scale, and building max scale, right? So now we can do temp scale x on the x coordinate, and then we're also going to do a temp scale on the z axis, and we're going to put the temp scale z on the building scale z coordinate. So this means we're going to have rectangular buildings, so they can have different widths and lengths, but they should still fit within the same variance of what we were looking at before. So as you can see, let me try to zoom in on one of these. You can see that the scale is different on this one than it was on the other one, and so on and so forth. So in this case, I can go back to my city generator here. Let's say the building min scale is 10 and the building max scale is 13. Or the min scale, let's make the min scale 2 and the max scale 13. So we still know the building spacing is 20. So now this creates us some major variance in between the so the width can be close to 2, or it can be anywhere up to like 10 each. So that'll give us some really interesting building shapes. And then so let's drop this building min height down to 20 and put this building max height up to 40. Let's add some more buildings to our mix here. So now we have some really thin buildings, some really wide buildings, and things like that. Oops, I keep flipping over. So now we have some really thin, wide buildings, and we have some thin buildings, and we have some thicker buildings. But let's go even further, because like look, I know that my building spacing right now is 20, so I can go anywhere up to 15. Before I start seeing them start to touch. So now we get some buildings that are really close to each other. So let's look at it. Let's look at it from the game perspective. So let's look down here. You can see that we have some space in between these buildings, but I feel like so maybe this is too wide. I like the size of the buildings, honestly. I like the size of the buildings, but I think we're gonna tweak them a little bit more. So I'm actually gonna go this up to like 24. Let's look at 24 spacing, and then make it a minimum width of 5 to 15. And so that should make some pretty, 5 thickness is pretty standard. And then, yeah, there we go. That's the kind of city I'm looking for. So there's our city. Now, something to note is that our city generator is right here. And none of our objects are inside our city generator. So what we could do, which is a very interesting thing, is that we could add this dot transform dot position, right? So it's this position plus the building spacing, right? So the object, so it gets the position from our parent object here, so our city generator game object. So it takes that position and then adds it to that. So that way it's always extending outwards from our position. Now this is important because now what we can do is something that's very that's in Unity. We can set the parent object. So in this case, let's look at temp. So we want to set temp.transform.parent, right, equal to this.transform. Now what that tells the temp object to do is to nest this object inside the other. So what we can do now is we can look at city generator. When I run it this time, you'll notice that there's an arrow on city generator, and when I select city generator, the object, all of my objects are spawned. So I can now manually move the entire city, or I can move one building. So the city generator now has all of the objects. So now I can say city generator 0, 0, 0, and the city generator should... So it generates from 0, 0, 0. Now if I were to say, you can see where it generated there. Now if I were to change the X position to 100, or let's say 300, so that's over there. It's going to generate the city over there because it adds the original transform of this to that. So now, if we wanted to, because I know how wide the spacing is, and I know how wide the buildings can be, I could potentially put the city generator as a prefab, and I can instantiate more than one city generator, and we can move these. So this one's 300, and so I'll make one 200, and then I'll make this one 100. And so, in theory, these will overlap a little bit. So, yeah. So let me back this one up to 0, and that one shouldn't overlap. There should be a little spacing in between. Because I know how wide our buildings are, how many buildings wide we are. We're 10 by 10. So what I could, and this is the last possible thing I can add to these public variables. So let's add so let's add to the bottom of this list. We will add building count width, and building count depth. Because we're not doing height. We're not doing height right now. We're doing width and depth. In this case, these values I want to initialize at 10 by 10. So now I can do width and depth. Oh, these have to be integers. I forgot, because it doesn't accept floats. But so we have integers, building count, width, and depth. So now I can go back to the editor, and I can determine how many buildings wide by how many buildings far. So we're going to just go with that for right now. But something to consider is that I know that each one of these city generators, how wide they are and how like and all that information based on the building spacing. So I know that the building spacing is 24, and I know that the building count is 10. So the object width is going to be at least 240, and so we can give it. But I know that the final buildings and the first building can be anywhere from anywhere up to 15, which is half of 15 is, we'll just do 16 for kicks. But half of 15 would be 7.5. So in this case, this is 240 plus 15, essentially. So I can actually position these almost perfectly. So we'll say this one's 0, 0, 0, and this one's going to be 240 plus 15 would be 55, 255. And that should make the two buildings have a little bit of gap in between these. So actually I probably don't need the 55. I can probably just say 240 and see what happens. So let's say it's so each one I can set is 240 apart from each other. So you can see that each one of these generates a new set of buildings. So I can do that one at 240, and I can do this one at negative 240. And so this should make 3 sets of buildings that all kind of sit right next to each other. And on top of that, I can create 3 more of these objects. I can do that, call it 4, 5, 6, and then translate these ones by, not Y, by Z 240, and so it'll create 3 more. You know, so now I have this giant city of all of these buildings. This city is huge, and I don't think for our purposes we need it to be that big. But now you can see how prefabs can make generating something like this much easier. So we're only going to go with 1 city generator because we don't need the whole thing to be that big. Oops, I deleted the ground as well. So we're just going to use 1 city generator object, and that's perfectly acceptable. So this one's going to be located 0, 0, 0. So because I know it's 240 wide, right? So our ground has to be 240 width. So notice that it's only 100. Well, I know that these at a scale of 1, 1, 1, this plane is only is 10 wide. That's something that the Unity won't tell you, but this plane is 10 wide. If I took boxes and I lined them up, this would be 10 wide. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Unity's grid here shows you that there's 10 squares wide. So knowing that, I can multiply the scale of this by 24 and 24, so that's 240, and then I can make the position by 120 and 120. So now the player's kind of is going to fall off the edge, so we're going to just make sure to nudge the player back on the edge here, and then generate the city, which should fit almost perfectly on the edge. Remember that there's a variance of about 5 possible, or 7.5 in either direction. So what we can do is we can then go back, edit ground a little bit, and we can scale this by 25 and 25, and now the city should fit perfectly on nope, not quite, 26. We'll go with 26. And this is just kind of number fudging at this point. I'm just messing with them to make sure that the whole building, all the buildings fit perfectly, and none of them are hanging off the edge weirdly. Oh, you know what it is? It's that because I did this by 120 and 120, I needed to do it by 100. 110. Because of the so the reason I'm doing 110 110 is because the I didn't account for the building spacing 24. It should fit pretty nicely right here. Yeah, that should do it. So in this case, that works out. Now we have our ground, right? So now we want to prevent the player from walking off the level. So in this case, we're going to create some walls. Similarly to just what we just did, we're going to create a 3D object plane. And we're going to, this one is 26 by 26, so we're going to scale this XYs by 26. So this object is going to be 0, 0, 0, and so then we need to move it out. We're going to rotate this by by 90 degrees, so now it's a wall. So if we let's rotate our player a little bit so we can see it. Oop, whoa, 180. Actually, 100. So now in our field of view here, we can actually see that it's a wall because it's been turned 90 degrees. So Z is going to be what, 24, I think. Oops. Negative 20. Yeah, I think it's going to be negative 20. So right now we're just kind of attaching walls. So this is not this is not be real sciencey. Whoa. So we want this probably to move 110 that way. Yep, perfect. So we want it to move 110 that way. Then we can clone that object and then move it across the z-axis by 100. We can do negative 90 so it faces the other direction, so it faces this way. Why is the z... Oh, it's probably 220 or 2... Oh, is it 240? Oh yeah, that's the spot. And then y of 25 or 5 because we want it to move up by 5. In this case, we want this to move up by 5 too. So then, now that we have those, we can clone both of those and then rotate them on their axes by 90 or negative 90. Oh no, we can't do it by the z there. We can do it by rotating them like that, or we can just yeah, no, this should be 90. I can't remember what I did for that one. So let's do it plane by plane. So in this case, I can transfer this one by 100 or 110, and then rotate this by 90, and then move it back. Instead of 0, it's 240 to go back there. And then the final plane of the day is going to come out like this, and it's going to get negative 90 so that it faces that way, and then it's going to, its X position is going to come to I think it's negative 20. Negative 20. So that should make it line up perfectly there, and that should made up in the corners, and now we have a perfect wall all the way around our level. So let's add a material to it, because materials. Create a new material. We'll call this wall mat, and let's see what color should we make this. We'll make this one green. So we'll make it real green, like green, and then we can apply this to our wall mats, to our walls here. I think there's a hole over here, but on which axis is the hole? Which one's not quite correct? There we go. It's that one. Okay, so bam. So now we have our walls. So let's create an empty object. We'll call this game walls, and we're going to set this value to 0, 0, 0, and then we're going to put all of the walls inside of it. Bang. Bing, bang, boom. Ah, what is happening? Locked up. Anyway, so now that we have our walls, let's make sure to save so that we accidentally don't get screwed up. Yeah, so it's not letting me turn the scene anymore. So let me close Unity real quick. I have to refresh. I must have clicked something that locked the scene. So let's Unity tutorial 2. All right, so now we're back to normal. Okay, so now if I start this, it creates our city with all of our buildings inside the walls. Great. So now we have all of our city stuff. So the next step is going to be projectiles and enemies. So you can collide with projectiles and enemies and stuff. So let's take a quick let's maximize this and we can take a quick tour around. And then we'll end the tutorial series with camera locking and things like that. We also are going to probably want to fix this iciness on the camera. So like I can start running forward and then I just let go and I just slide until I bounce into something. So we can fix that icy camera real quick. So or the icy player. So the player, all objects, this is an interesting one, all objects on this capsule have a physics material. So under our materials, we're going to create a folder, and this one's going to be called physics. So in our physics folder, we can create a new physics material, right? And we're going to call this material ground physmat, PHYSMAT. Ground physmat. Now you can see that there's a bounciness and a static friction and a dynamic friction and things like that. You can change the friction combined and the bounce combined, its average and things like that. So what we're going to do is we're going to apply our ground physics to our ground, and then we're going to create a new physic material, and we're going to call this player physic mat. So in this case we have a similar friction mat, and we're going to apply that to our player. So now you can see that our player has a physic mat and our ground has a physic mat. So now what I can do is I can set the ground to have varying types of friction. So in this case I walk across the ground, and the ground I slide across the ground because friction, and the friction is low. So let me turn up the static friction to 21. Alright, fine. So now we have the friction. Now again, I can change anything here. So I can't even move because the static friction is so high. So let's move this down to like 3. So instead of 0.6, it's 3. Now I can move, and the friction eventually brings me to a stop. But it also means that I move slower on this material here. So in this case, the dynamic friction would be maybe something I want to play with. I want it 0.6, not 0.06, and then I want this to be, let's set the dynamic friction to 3. So let's see what happens. So now now the dynamic friction, I can't move anymore. So let's see the dynamic friction of 1. Yeah. So in this case, the friction slows me down a little bit faster. I can set this up to 1. And in this case, I will copy this is because this is this is something else to note. So remember how I said when I change something here, it resets? Well, if you go into your prefabs, into your assets, and you change things while live, these will save. So for example, I'm changing the ground fizz mat, and these will save when I leave the editor. So in this case, so now the ground fizz mat allows me to it's very difficult to move around because actually I think the player is in a building right now. Player, where are you? Yes, the player is in a building. So I'm gonna wanna change that so that the player does not start in a potential building by starting it all the way in the corner, since I know that there's a little bit of gappage in the corner, so the player will never start out in a building. So the player can move. The player will come to an eventual stop. But we can also change something about this. So let's set this back to a 0.06, not 0.6, 0.6 friction, where it was kind of icy before. And we can actually go back to the player and change something about the rigid body. So now the rigid body has a mass of 1, so I'm using a force of 10 to move a mass of 1 by a certain amount. So let's add some drag. So I can add let's add a 2 drag to the player. Now, adding a 2 drag to the player will cause the player to move slightly slower, because that's the drag. So what I can do then is increase like the force. So let's say I bump the force up to 30. I can now move a little bit faster, but now I come to a stop a lot faster because the drag affects my velocity. So in this case, this is a little bit better for me. The only downside to using drag is because the drag applies in all directions. So jumping becomes a very difficult problem because if you're using the rigid body for jumping, the drag will also affect your float. So you'll float downwards instead of falling at normal gravity speed. So that's why you want to use like a combination of drag and friction in order to create your game friction stuff. So in this case, I can, because I have the drag of 2, I can now increase the player momentum to about 30, 35. We'll do the player, make the player move a little bit more swiftly. But that's how you will increase the player's movement speed, is by increasing that. And the force, the thing with that was the other thing. By adding force, we're actually using the physics engine and not moving it by a constant rate. You could potentially go back to our code here and go into our player movement and change the instead of rigid body add relative force, you could potentially go this dot transform dot position. I believe you can equals this dot transform dot position plus new vector 3, I believe, something like that. You could basically, instead of applying a force to a rigid body and having the rigid body handle the movement, you could potentially just transform by a speed, and that would give you a little more control over the rigid body or over the controller. And I'm not getting into it, but if you want to look more into that, look into the physics character controller object. And this character controller allows you, it does some voodoo magic behind the scenes to make the player move at a constant rate. But this is, I think, a better solution for right now. For simplicity, we're just going to move the rigid body around. So now we're going to, now that we have our level and we have our walls and our player and our camera movement, the next thing is putting enemies and being able to shoot them. So, you know, because shooter. So that will be the next video.